Hello, my name is also Doliner. Today I'll be performing lap 9. Okay, let's now begin with part A. Right now I have the simulation set up. We can see here, I'm going to run it again. Just test, set run all. And we can see that it operates right now in the lower left corner. We can see that it runs well. No errors seen. And right now in the waveform, let's go to the beginning. I can see that my input count, at the beginning I let it run for 2 clock signals, so it counts 0, 1, 2, and then I set the clear to 0. So basically what happens is that it clears out, so the output count would reset back to 0. And then also when this clear goes back high, I have it set up so the enable goes low, and we can check both right next to each other. So right now the enable is low, and we can see that the count remains at 0. It doesn't increase for the 2 clock signals that it's low. So we can verify that it's working here on the test bench. At around 600 milliseconds, we can see that right here where the cursor lies, we can see that with the enable goes back up, and then the count begins. And right here I also set up the expected value for the count here at tempq, and this will begin counting right at the same time as the regular or the actual value of the counter. And we can see that it goes 1, 2, 3, 4, and so on. So we can see that the test bench clock also is synchronized with the actual value of the clock, and we can see that also the hex values align as well, so we can see the same expected output at both ends. We can also see later on the waveform, this is for the first or the lower digit. We can move on the waveform, and we can see that after the first 4 bits are high, we can see that then the next hex display turns on as the digit rolls over. So moving on, we can see that essentially the counter operates as expected, as well as the test bench. And we can move on to the end. When we get to the value of 63, which is a string of 6 bits high, we can see that then the count ends, and we can see the end sim variable then turns back high. And we can see that the simulation ends at this point with no problems. So that's it for this part. We're now going to check whether or not it corrects errors on the simulation as well. So I'm going to break the code and see how it works. Right now, the only change that I've made to the original code is that I have set the qtemp input. So to say the counter state, when the reset bar goes low, the counter will be at 1 instead of 0, and that should break essentially every part of the code, because we're checking first with the clear. So at the beginning it will count fine the first 2 times, then when we hit the clear bar, it's gonna go to 1 instead of a 0, and that should alter all of the counter states. So we're gonna see that now on simulation. So I have already loaded everything up to our waveform. So let's simulate and see how it works. So we can see that we get a bunch of errors. We can scroll up and see at the beginning. So we can see that counter failed to reset. Why? Because we're comparing it to 0 on the test bench, but it loaded at 1, so it's gonna show an error right at the resets. The enable also failed because we were at a 1 instead of a 0 right there at the first part of the code. And when we start counting, everything is gonna be drifted by 1 value, and we can see that now at the waveform. So let's move back to the beginning, zoom out, we zoom back in where we want to look. Right there at the beginning, let's arrange this better so it's easier to see. We have up here our temporary code. We don't know about that yet because it's not loaded yet, but our Q out, the actual value, we can see that it goes 0, 1, 2, and then resets to 1. So at this point, we have a 1 loaded. The test bench sees that it's not a 0. It throws an error. Later on, we can see as well, this is a 1. When we hit enable, it remains at 1 instead of 0. So it hits an error. Right now, here it sees that this is a 0, the expected value, and we have a 1 here. So there's definitely an error there. And all the way throughout it, we can see that it's lagging one count behind, basically, or the expected value is lagging 1 count behind. And we can see that all the way here. And we can see that also the messages are shown appropriately. So we can see that the card enable failed, it failed to reset, count of 0 fail, hex display, so hex 0 output fail at count value 0. And then yeah, we can keep looking at that from there, because you see count of 1 failed, hex 0 failed, so on. And let's check on the waveform, because oh right, and we don't see here the effects it has on hex display 1 yet, because loading a value 1 doesn't necessarily mean that the second digit will go wrong that right away. So we're gonna need to scroll back down a little bit to show when it does, which should be on the value of 15. On 15 or 16, we should see that hex 1 fails, and here we goes. How hex 1 failed at value 15. Why? Because when it rolls over, one of the values rolls in first, and it throws an error. And that's gonna be seen all across the test bench. And when it loads up a next value, we can see that as well. And that will be it for this part. We begin now with part B. Right now I have the counted, the show, or so to speak, the output enable pin low, so we don't see any signals. When I flick it up, I can see that the counter regains its previous state. So it was counting all the way even, so we can see that if I disable the counter, it keeps counting even though it's not being shown to the user. So I'm going to put it back up. Right now we can see that it's a BCD counter, because even though this might look like it counts seconds, when this goes up to a greater number than 6, it's going to keep counting. So it's going to be 7, 8, 9, and then it's going to reset. So that's how we can know that it's a BCD counter. We can also disable counting, and it's gonna stay in place. This by using switch 1, which is our count enable. And when I put it back up, it's gonna regain its counting state. So it's kind of like putting a stop to a stopwatch, so to speak. Put it back up, this goes. I can also disable it and then turn it off the display, and it's gonna reflect the same output as before. With the reset pin or the reset switch, I can reset it back to 0. I'm just gonna wait until this goes to 7, so it shows that it's a BCD counter basically. And yep, basically it follows all the features. So right now I can see that it goes to 7, so it's a BCD counter. It's not just a regular timer in seconds, minutes, hours. And when I put the reset low, I'm gonna see that it resets back to 0 and it doesn't count because the switch is low. I'm gonna put it back up, it starts counting again. I can disable it and I can turn the display off. I'm gonna start the timer. Right now it's at a higher frequency, and we can see that all the states will show up. And now it resets. So that's it for part B. Now we begin with part C. Right now we have the reset input set to low, so we have all the outputs set to 0. when we push it on, you can see that it counts approximately once every second, and we can see that when it gets to 9, it would roll over to the next digit, and so on. So this operates as in the lower seconds, so the lower digit for the seconds, the upper digit, and it's gonna count until it gets to 60, so 1 minute. And when it gets over to 1 minute or 59 seconds, it's gonna roll. This is gonna go to 0, and once it will be past this digit, this will indicate the minutes that's going on, and it will count until 59 minutes. So basically it's an hour clock, so to speak. After this, after it rolls to the 1, we're gonna speed up the clock so we can see all of the digits rolling over, so we can see all the counting sequence. So right now we can see that it rolled over after 1 minute. So let's speed up the clock and see how it operates. Now we have this sped up clock set, and we're gonna look at the counting sequence all the way. Right now we're approaching 59, and we'll see it rolled over back to 0. And there we go. That's it for this lap.